Good morning, everybody. We're going, and all of you SAT lovers, we're going to do a section, and I'm going to go through it fairly rapidly. I can go into more detail later, and hopefully it'll make more sense to you, and we will get started right away. So what I'm going to do is I'm looking at this equation, and I'm going to subtract 2x from both sides, and I'm going to simplify this negative 3 and this negative 2, and I'm going to get 4x minus 5 is equal to 7. And I'm going to guess that most of you can solve that. 2 steps in your head, bang, done, and move on. If you need to see it, here it is. You do the opposite to both sides in reverse order. So we add 5, and we get 4x equals 12. And we divide by 4. And of course, we get x equal to 3. I like to write my letter on the side, and I like to give it a star because I'm absolutely certain I'm correct. This is a real-world graph, and it's got minutes in the x-axis and distance in feet in the y-axis. This is y equals mx plus b. Notice that it's going through the origin, which means that the b is equal to 0. Y equals mx plus b. And so all you need to do is identify the slope, which is the m part. Since b is equal to 0, this one is c is out, and d is out, because we're not going through 0, 2, we are going through 0, 0. And we have a slope of up 2 over 1. Up 2 and over 1, and of course that's going to be A. And again, I like A. I put it up next to the number, and I'm absolutely sure, and I'm going to move on. Let's take a look at question number 3. These are sometimes called literal equations. We're going to solve for a variable in terms of the others. And what we want to do is solve for P. So we're going to get P by itself. P is going to act like our variable. Everything else are just numbers. And our first step is the last thing we did to P. And the last thing we did to this side of the equation is divide by 6. So in order to simplify this whole thing, I'm just going to multiply by 6 on both sides. And that's going to eliminate that 6. Now I'm almost done already. I end up with 6e is equal to O plus 4m plus p. This is an O, not a 0. Now, I'm going to guess most of you know what to do next. You're going to solve for p, so we need to get rid of the O and the 4m, and we're just going to subtract it from both sides. Subtract the O, subtract the 4m from both sides, and we are done. There's our solution, and it looks like it's going to be P equals 6e minus O minus 4m, which is A. And again, I'm pretty sure, so I put a star. I like classifying my answers, and I'll show you how do I classify other answers another time. Number 4 is a geometry problem. And the first thing I notice is that this angle is the rest of this 114, and it's the rest of the 180. If you can subtract in your head, that's great. If you can't, you can take 180 and subtract the 114 and get the answer. This happens to be 66 degrees. Notice that adding these two will give you this exterior angle, which is 97. This is 97. Or you can add them together and subtract from 180. Looks like we're looking at 83 for this one, huh? And this one makes 83. A lot of information. The problem is that they gave us, they want us to find this angle down here. And the trick for this one is that they told us that RT is equal to TU, which means that this angle, this side is equal to this side, and this is an isosceles triangle with base angles equal. I have base angles equal plus 114 gives me my 180. So I'd normally write x plus x, but that's going to mess me up. So I'm going to call it r plus r, or b plus b for base angles. B plus b plus the 114 gives me the 180. And I've already subtracted that before, which gave me 66. And I get b is equal to 33. Now, again, I'm not quite done yet. I still have this 33, this 83, it looks like, and a missing angle here. So 83 plus 33 is 116, and I have to add my angle to get my 180. And so that's going to give me my 64, which is C. Very, very difficult problem, way longer than I usually spend on SAT sections. All right, number 5. It says the width of a rectangular dance floor is W feet. The length of the floor is 6 feet longer than the width. We've got a dance floor, it's rectangular, we've got W, L is equal to W plus 6, and they want the perimeter in terms of W. So I'm just going to add up all the sides, W plus 6, W plus 6, W plus W. That's going to give me my perimeter. If they had asked for the area, I would multiply W times W plus 6. In this case, I'm just going to add up all my W's. I get 4W plus 12 gives me my perimeter, and I can be very sure of that one. Number 4, I would not put a star on it. What I would do is I would say I'd put a check on it because I'm pretty sure it's right. I may look for another way of simplifying it, making it a little faster. Hard to say what way might be quicker. It might be quicker to use this quadrilateral and this 33 degrees, possibly. All right, number 6. This is an interesting one, and I found a way to simplify it a little bit better. But my first impulse was to say, okay, I know y is greater than 2x minus 1, so if I can figure out the smallest value of x, then I know that y has to be bigger than this. And the smallest value of x is 2x has to be greater than 5. So I know that x has to be greater than 5 over 2. Since x has to be bigger than this, y has to be bigger than that. If this had been negative, it would have given me all sorts of problems. But as it is, it's pretty straightforward. Substitute the 5/2 in for x, and you can figure out what y has to be bigger than. So y has to be bigger than 2 times x minus 1, where x has to be bigger, than the 5/2. We put the 5/2 in, the 2's cancel. Y has to be greater than 4. And I'm pretty sure on this one, I would say check. I'm going to double check it by doing the following. I'm going to do something that's a little weird. What I want to do is it says that y is greater than 2x minus 1. And this looks a little bit like 2x minus 1. It's just missing the minus 1 right there. So what I'm going to do is I'm going to put a minus 1 right there and a minus 1 right there. And I'm allowed to subtract from both sides. Watch what I'm going to do. Y is greater than 2x minus 1. And it says down here that 2x minus 1 is greater than 4. This is something like a transitive property of inequality, which again gives me my y is greater than 4. And at this point, I've double checked it. I am very sure it's right, and I move on. Number 7 is, looks like you're going to be looking for a solution set for the equation above. And there's a lot of ways of doing this. My first impulse was to subtract the 4 and get the square root of 2x plus 6 is equal to x minus 1. And what I'm going to do now is square both sides to get rid of the square root. But there is another way to do this. If you're not very adept at solving equations, what you can do is use the solutions to try to see if it works. Now I'm going to try -1 because that's the very first solution I see. These are called solutions. And if -1 makes this true, then I know that the answer has to be this one or this one or this one. If -1 is not true, then I know for sure what the answer is. So I'm going to put -1 in here. And this gives me -2 plus 6, which is 4. And is that equal to -1 minus 1? Is this true? I just put a -1 in for x, simplified it. That's -2 plus 6, which is 4. The thing that you got to keep in mind is that square roots have to be positive. So this has to be a +2, and it is not equal to a -2. So -1 is out, which means that this one is out, and so is this one. That only leaves me one solution. And what I'm going to do is I'm just going to put a little check mark next to it. Now, I could come back and put 5 in and make sure that it makes it true. Let's see if 5 makes this true. Let's see. If I put 5 in the original equation, I get the square root of 16, which is 4, plus 4. And is that equal to 5 plus 3? And it is. I've double-checked it. I am absolutely sure. I move on. This one is a polynomial expression. We're taking f of x and dividing it by g of x. And so what I end up with is x cubed minus 9x over x squared minus 2x minus 3. These kinds of expressions need to be factored. And the trick for factoring them, we look for common factors. It looks like we have an x in both parts of this. So this is x times x squared minus 9. Hopefully you all recognize the difference of squares when you see it. Now I'm going to factor a little more, and I'm all done. Because this factors are easy. X plus 3, x minus 3. X plus 3, x minus 3. In the bottom, I've just got x minus 3 times x plus 1. I'm factoring this by looking at the product and the sum. Multiplying these gives me -3, adding them gives me -2. I simplify out the x minus 3, and I end up with x times x plus 3 over x plus 1, which is d. And I'm absolutely sure. This one, it says, in the xy plane, we have a graph of a circle. And it says point P is on the circle, and it has the coordinates 10, -5. I know that this circle has a center at 6, because that zeroes out this part, -5, and it has a radius of 4. That's what this says right here. This equation says I have a center at 6, -5, and a radius of 4. And if I go to 6, -5, there's 5, there's 5, let's see, 6, -5 is right about there. And I have a radius of 4, so it looks like it's going to cut just a little bit below there, a little bit below there, going to come in here, going to go out here, and it says that 10, -5, here's 10, -5 is on my circle, which we kind of expected. And here's my circle. And it says PQ is a diameter. So there's my P, yep. And here's my Q over here, because this is a diameter. This distance goes from 6, -5 to 10, -5, has a radius of 4. Go 4 back, and you've got your answer. And we know exactly where this is. And hopefully you guys can see that it's a 2, -5. There's my answer. This is a group of 202 people. We've got 60 tents. We've got 2-person tents and 4-person tents. This is a very classic system of equations problem. We've got 202 people in 60 tents. We've got 2-person tents and 4-person tents. 2 people fit in the 2-person tent, 4 people fit in the 4-person tent, and we have a total of 202 people in tents. And the 2-people tent plus the 4-person tents is equal to 60 total tents. And there's our system of equations. Now, the trick here would be, I would just solve it just straightforward, multiply the bottom by -2, and, finish solving by using addition method. Some people call it elimination. I'm just going to get rid of the -2 by doing that. The other option is to just substitute in to both of these equations and see if one of these works, if you're not sure how to do your solving. Of course, this is a lot faster. I've got -2, -2, and -120, and those cancel out. This is 2f is equal to, it looks like 82. So f is equal to 41, which is not the answer I'm looking for. I need the other 19. And C, I'm finished, I'm pretty sure. I might put the 19 in and see if it's true, just to double check it. Let's see, 19 and 41, 41. And make sure that that's 84 and 38. And 84 makes 202. Yeah, no, that makes 212. What did I do wrong? That looks right. Let's see. No, I think it's okay. Let me see. 38 and 82. Nope. 4 times, 162. 164. And 2 and 1. There it is. Okay. I kept multiplying by 2 instead of 4. Anyway, there it is. It's correct. Nice little polynomial. This is a 4th degree polynomial because it has a W curve. I call this a double root at 0. X equals 0 is a double root. I've got a single root at x equal to 2. And I've got a single root at x equal to -3. And if you know about roots, it makes it really easy. The roots make the factor 0. So one of the factors of this is x plus 3. And another factor is, actually there's 2 factors of x. Because a double root, there's always 2 of them, because it touches at just one point. And this one is a single root, so it's x minus 2. So I just multiply these together, and I already know what my polynomial looks like. And there it is. B is the answer. If you don't know about roots and factors of polynomials, that's a really good thing to learn how to do to estimate your functions for your polynomial functions. Find your zeros and go back and forth. Number 12 is a beautiful question. SAT loves to do this. What we're used to doing is solving for an X or a Y or an A or a B, and then substituting it back in and finding the value of the expression. What I'm going to do is I want to get this expression, I want to solve for the expression, kind of like what I did in number 6. So what I'm going to do is I want to get B over A. So I'm going to turn this over. I'm going to do the reciprocal. B over 2A is equal to 2 over 1. Now I'm almost done. I have B over 2A, but what I really want is B over A. And in order to make it that look like this, I just have to multiply by 2 on this side, multiply by 2 on that side, and look what happens. The 2's cancel out, and I get B over A equals 4. Done. Moving on. I love these kinds of problems that you solve for an expression. This one looks like we're looking for a function, and it says that in the year 2000, we had 4 million barrels, and we had 1.9 million barrels in 2013. It's going down. which means that this function has a negative slope. All I need to know about it is right there. I have a negative slope, so I know these two are out. Now, another thing, it says that we're talking about t years after the year 2000. So my initial year, we call it year 0. When we talk about time, we like to start out at 0. My year 0 is 4 million barrels. Notice that all of these y-intercepts are 0, 4. That doesn't help us. But the 13 years later at 1.9 does help us, because what we want is a slope. 4 minus 1.9 is 2.1, and 0 minus 13 is negative 13. There's my slope. And if you look at this, you can see that this just multiplied by 10, and there it is right there. All done, moving on. Oh, I like this one. Okay. They didn't quite put it in y equals and y equals terms. So what I'm going to do is I'm going to make this y equals a quadratic. So there are 3 possibilities. By the way, there can't be 4 solutions. There are 3 possibilities. I could have the possibility that I've got a line that just touches at one point, kind of like that. I could have the situation where it touches at 2 points, or I could have the situation where it doesn't touch the quadratic at all, because this is a line down here in the second equation. Well, what I'm going to do is I'm going to add 5x and subtract 8 from both sides. So I'm going to get y equals 5x minus 8. There's my line. And I could maybe graph it, but that's going to take me a lot of time. I'm going to try solving it. X squared plus 3x minus 7. And let's take a look. We've got 2 equations. Sorry, this is getting out of hand here. There we go. Now it's a little nicer. Sorry about that. This one, I added 5x to both sides. I subtracted 8. So I got my equation for my line. I have a quadratic here. It's already written. And I've got x squared plus 3x minus 7 equals 5x minus 8. And if you know how to solve quadratics, you just subtract the 5x and I add the 8. And what I get is 1 negative 2x and x squared, x squared minus 2x plus 1 equals 0. Ignore that. Man, that sure looks like a perfect square trinomial there. That's only one solution, x equals 1. And I can see that it makes it true because that's negative 3, and that one is negative 3. There is exactly one solution, which is C. Tough question on number 14. No real nice way to do it. It looks like it's in this kind of situation. Of course, the graph is actually on the other side, but there you go. Well, no, it's actually here, where this is a 1. There it is. All right. These, for whatever reason, give people all kinds of problems. Normally, these get harder and harder as you go, and a lot of people miss this, and they really shouldn't, because I want you to see something. H of 0 is asking for what happens when I put a 0 instead of x. Put a 0 instead of x. So watch this. H of 0 equals 1 minus g of 0. There. That's true. Now, they told me that g of x is equal to 2x minus 1. Well, I have a 0 instead of an x. So I'm going to put this right here, g of 0 is equal to 2 times 0 minus 1, because I'm putting a 0 instead of x. Well, that's negative 1. This goes here. Negative 1 goes right there. That's a double negative, so I get 2. Done. That's it. D. Finished. Notice all I did was replace the x with a 0. That's all I had to do. See how we're doing for time. I'm not seeing my time on my recording, but it's okay. All right. Now we're going to do some of our open-ended. It says A is the solution. Well, you should be able to factor this. We're going to factor it because it's equal to 0. It's going to be x, and I need a negative 12 when I multiply it, and I need a positive 1 when I add it. I'm talking about 4 and negative 3. I've got two solutions. 3 and negative 4 makes this true. And I want A to be greater than 0, so the answer is 3, and I'm absolutely sure. I've got the sum of two polynomials are going to be written in standard form, quadratic, and I want to add A plus B plus C. So, lots of additions. Negative 2x squared plus 3x squared is 1x squared. X plus 7x is 8x. And 3 plus negative 8 is negative 5. And I'm going to add negative 5 plus 8 plus 1, which is 4. And I'm done. Number 18, we want to solve the system. It's set up so beautifully for addition. I can just add it together and get 4y equals negative 3.5 plus 9.5, which happens to be 6. Divide by 4, and y is equal to 3 over 2, which is perfectly acceptable answer, or 1.5. Either one is correct. This is probably the safer one. What you don't want to do is put 1.5 in your answer because it'll read it as 11 halves. So be careful when you put your bubble in your answers on these kinds of problems. This is 3 over 2. Only two more. Number 19, a startup company opened with 8 employees. That's their starting point. And the growth plan assumes that 2 employees will be hired each quarter every 3 months. So each quarter, we're going to get 2 more, 2 per quarter. And it says y equals ax plus b, y employees for x quarters. So we're talking about how many people per quarter are we adding up. After the company opened, what is the value b? Oh, wait a minute. B is the starting point. There it is. It actually happens to be y equals 2x plus b, where b is 8, of course. That's the starting point. And we start out with 8, and then the next quarter we have 2 more, and the next quarter we have 2 more, yada, yada, yada. B is 8. That's the answer. That's all you needed. The starting point. A lot of verbiage here and not a lot of work. Last one, we have what's called a central angle on this circle here. And it says that BC from here to here is 2/5 of the circle. Well, we want the central angle. And 2/5 of the circle is how much of a whole circle? Well, that's out of 360. 5 goes into 360 72 times. And 72 times 2 is 144. Let's see if that seems reasonable. 144, 2/5 of the circle. Looks good to me. Looks like we're done. And hopefully it didn't take us more than 25 minutes. I tried to explain it and do it at the same time, and sometimes that doesn't always work out. But hopefully you got them, and you got them right too. And I will see you back when I do another one. Bye.